Hey guys, what's up? Welcome to the latest lecture of STAAD PRO classes. Till now, we have learned in parts about how to make our structure, add loads, member forces, etc. So now let's put all of them together to analyze a real life simplistic example. This is a one-story, single-story storehouse. The architectural views of all that. So you can see this is made up of grids of 15 feet by 15 feet. And let's try to make the structural members. Let's try to design the structural members for this given building. So for our convenience, I have already made the 15 feet by 15 feet layout in meters actually. So let's start modeling our structure. So let's go for selecting our node, selecting all the nodes, giving isometric view, going for translational repeat. We will translate in y direction, and then the first step will be 1 meter for our foundations. The second step will be say 15 feet only because we have a height. Store should have a good height for 4.57 meters, and then link steps. Okay, so see, we have our uh, structure with all the beams that we require. Now let's go for adding beams. The first thing is that why I took a real life example. Just see the plinth beams when we give, we do not give in every section. So that is why from nodes I went for a translational repeat. Now let's cut section one by one. Shift plus N will give me the the node number. Then I go for cut section with we will go for XZ plane. Say I'm going for the top with node number. We can see here 41. Okay, so we have got that plane. Now let's go for add beam, add beams, add beams. Individually we can go for add beams. Just go on adding beams. Now the thing is that just see on the roof slab we need to provide beams everywhere, but in plain beam we need not provide because there is already a ground support that it will get. Though we design for a frame structure, but then also there are no floor loads on the plinth beam. So why to waste our cost on that? So let's put these things together. Yes, save. This is a very nice feature which automatically asks you to save. We go on for add beam, simple and sweet. Add beam, add beam, add beam. So now you can view our structure. The upper part of our structure is ready. Then now let's go for the lower part of our structure, that is the plinth beam. Since this is a single story beam, a single story store, so we have gone for the roof beams. These beams are of roof beams. So let's go for again cut section. We go for the XZ plane with node number say 21. Okay, so now let's add only the peripheral beams. Let's make our plinth beam only peripheral. Going on adding our peripheral beams. Now we'll be adding all these beams to the longer spans just to tie them together, just to decrease our effective length and nothing else. So let's view our whole structure. So we have done the entire plinth beam network. Now let's go on to geometry. We have completed geometry. Let's go on to general. We'll give the material property. So go for define. We have a rectangular section. Say the depth of this is the depth of the beam. Let's first think about our roof beam. Let's give it a 350 depth. The width of the beam is obviously the width of the wall, 10-inch wall that we have. Add. Then another the column. Let's go for a 400 mm column. 400. Add the plinth beam. Let's go for that one, pretty small amount. So 250 by 250. Let's select that for the plinth beam. Add. Close. Now let's select the member one by one and assign them. So for plinth beam, let's select the whole plinth beam. Let's see if the whole plinth beam has been selected. Yes. So assign to selected beam. Assign. Yes. Then let's go for that roof beams. Roof beams. Sorry. Roof beams. Selected beams. Assign. Yes. Then we'll go for the columns. Select. We'll go for beams parallel to y-axis. So all the columns get selected. So here assign to selected beams. Assign. Yes. So we have already assigned the material to each of our members. Now let's go for the support. We'll go for a fixed support. So let's create a fixed support. Add. So we have made a fixed support. And then we have this node cursor automatically on. Assign to selected nodes. Assign. Yes. So see, all our bottom nodes have got the fixed support. Now let's go for the loads and definitions. Let's create the load case details. Actually, I'm going a little bit fast because these things are already being done in our previous lectures. This is dead. So let's name it as dead. Add another one, live. Let's name it as live. Add. Then let's see if this dead load and live load have been added. Then let's go for define load combination. The third one, let's combination. Let's name it as combination. As per IS code, we go for 1.5 load factors. Dead load 1.5 load factor, live load to 1.5 load factor. Add. Close. Now let's define dead load one by one. Add. The self weight factor -1. Add. Then we have got a member load. Member load, that is the weight of the brickwork. So what will be the weight of the brickwork? The weight of the brickwork will be on the plinth beam. So for the given height of the building, we can find weight of the brickwork is something around 16 kilonewton per meter. So let's add that 16 kilonewton per meter. Add. Yes. Save. Then we go for the floor load. These are all the dead loads. Keep it in mind. Fine. So for say 125 mm thickness we are going, the floor load comes out to be 3.125. But because it is a roof slab, we will also be having some waterproofing treatment, some grading, some finishes. So let's take it as -4.5 kilonewton meter square. So the minimum range that we need to define, say 2 meters, because 1 meter is our foundation depth. The plinth level is 1 meter. Maximum, say we can have 6 meter. Add. Close. So this thing we have assigned. This thing we have assigned. Another one I left. Add. Because there will be parapet at the top, we will have another member load. Say that as -4 kilonewton per meter. Add. Close. So the self weight, it will be the assign to view, because everyone will be having a self weight. Assign. Yes. Then this is the -16 kilonewton. This is for the brickwork. And where will we have the brickwork as per the diagram? Just see, we have the brickwork on the periphery, totally on the periphery. So we'll be adding the brickwork on the periphery of the plinth beam. So first let's cut the section. Cut section, XZ plane with node number 21. Okay. Then we hold the control button and select members one by one. Or we can first go to the plan, then select as a whole. Press control button. Standard computer controls will work here. So we have selected the whole plinth area on which there will be the 16 the brickwork load. Assign to selected beams. Assign. Yes. Then let's view the whole structure. Then we have to assign this dead load of the parapet wall on the top of the terrace floor. So let's go to cut section again. XZ plane 41. Okay. Then let's go for the top view. Let's take it one by one. Side, control, 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 select, and then let's see. We have selected that. Assign to selected means assign, yes. So we have already assigned the loads. Now let's give the live load. Live load new, sorry, live load add. These are all the floor loads because live load will be on the floor. So let's give a live load of say 3 kilonewton minus 3 kilonewton per meter square. Add, close, and then okay, we have just see we haven't given the range, correct. So the range will be from 2 meter to say 6 meter. Change, close. See, the live load also got added. The combination of load also got added. Here we are not considering the wind load because this is just a single story building and we are just going to analyze because we haven't analyzed a single structure till now. I'm just going to teach you how to analyze a structure. Fine. So just we are giving the basic load components, the basic load cases that we have, and we will be analyzing the structure based on that. So now let's go for the analysis and print. This is perform analysis, all, select all and then add, close. Then we'll go for the design of the material. Now here you see we have to design with it steel, concrete, timber, aluminum, shear wall, anything is there. But since we have selected concrete in geometry just see in general we have selected the property as concrete. So we'll go for design with concrete. Fine. The first thing that you have to do here is select the IS code. IS 456 is in which we are going to design. Then select parameters. What are the parameters that I'll be setting for my designing? Say what will be the grade of concrete. In left you can see all the parameters that we have. So we'll first go for the grade of concrete. Say this is the compressive strength of concrete. This I want to define. What I also want to define is also the steel, the grade of steel. FE 500, FE 550 or FE 415 or FE 250, anything that we can go. That is the primary, FY main, FY secondary. Then what I can do is that maximum, the maximum size of reinforcement if I want to limit. Say I am doing it in a very remote place where I don't have the access to 32 mm dia or 25 mm dia or higher diameter reinforcement is not available. In that case, we have to give this one. Then let's define this one also. Let's define the maximum secondary too. We'll also go for minimum one also. Let's say the minimum, sorry, the minimum size also we'll be defining. The minimum size for secondary also will be defining. Let's define all this. Okay. Now we have selected the parameters. Now let's start defining the parameters. The first is the grade of concrete. Let's take it as M20 grade of concrete. This is because this is a very rudimentary example. So let's go for the least possible things that we can have. FY main. Let us give it as 500. And FY secondary. Let us also give this as 500. Maximum main. The maximum, let's give it as 25. Fine, we are going somewhere. Add maximum secondary, the secondary reinforcement, let it be 10 only. Add minimum main, let's give it as 12 because the minimum reinforcement in this column is 12. So let's give it as 12. Add minimum secondary is 8. Add, close. Now just see we have all these parameters here. The code Indian has been selected, start concrete design and FY2. This is the FC, the grade of concrete. Now let's assign it to view because everything will be designing in the same grade of concrete. So assign, yes. Then the main reinforcement. We will also use FE 500 for all. So this is also assigned to view, assign, yes. FY secondary, then again assign to view, assign, yes. The maximum main to view, assign, yes. Maximum secondary, assign to view, assign, yes. Minimum main, assign to view, assign, yes. Minimum secondary, assign to view, assign, yes. Now we have already given the parameters. Now let's start designing them. So we go for commands and design beam, add, design column, add, and then we haven't given any slab section. The designing of slab I'll be teaching in another class. Then this is the takeoff. This is the quantity takeoff, means the total volume of concrete and weight of steel that will be used in the whole structure. This is a very good feature actually. Add, close. Now let's assign them. Design beam. Which are the parts of the structure that we are going to design as a beam? Because you know the property of designing a beam, the method of designing a beam and column are different. So we'll be selecting the top, this top part, and the terrace beam and the plinth beam to be designed as beam. Just see the whole thing that we have selected, design to beam, assign to selected beams, assign, yes, design of column, select beams parallel to Y, all the things got selected, design column, assign, yes. So just see, we have given all the commands to design a beam, to design a column, and also have a concrete takeoff sheet. So now what we only have to do is analyze, run analysis, save, and for the first time we have started running our analysis. It might take some time to run the analysis. Just see, started running the analysis. Yeah, we have got the analysis is over. So now let's view the output file. Done. Now see what it has done. Concrete quantity here, that thing that I was telling about, the total volume, this is because we have given the takeoff. So that is why the total volume of concrete is 29.8 cubic meter, and the bar 8 dia bar, the weight will be required is 9152 kgs, 12 dia bar will be this much kg, 16 dia bar will be this much kg. Fine. So now if we go to the top, we'll find what is that the whole design has been given here. Say this is beam number, this is the beam design. So what it will give? It will give 4 sections, 1, 2, 3, 4, 5 sections it will give. At each section what is the quantity of steel that is required. Here just you see what it has given, M20. So we are going for the M20 grade of concrete. Fe500 is the grade that we have given. The size of the beam is given. The cover that we have opted for is 25 mm. The length of the beam is 4.57, that is 15 feet. Now the every design that it has given, 412, then 312, in between 212. So we'll have extra top of 212 bars extra top here, 112 bar extra top here, with 212 bar continuing throughout. In bottom we have 212 here, 312 here, 212 here. So we can go for an extra bottom in this 1.142 to 3.42 meter, that we can have a total beam structure there. The reinforcement distribution like that. So similarly everything it has given, we can search for the column, say column. Just see here the column design results are there. That was the beam design that we saw. Now it's the column design result. The first column that it is giving, the area of steel, provide 8 dia rectangular ties at this much, provide 8 12 mm dia bars. This will be the square root. How it is distributed, what will be used, the ultimate the force, vertical force, that is the moment. This is the moment along z axis, moment along y axis, the interaction ratio that we find from the interaction diagram for the given d by d dash, and also the given Fe level. We have an interaction diagram in SP16, that is the interaction ratio that it has been referred to here. So in this way you can find that it has designed each and everything. But here you need to again re-reference which one is column number 3, which one is column number 1. So what you can do easily is that on your structure you can double click on a member. There you can see the property, the loading, the shear bending, the deflection, the concrete design. Everything it has shown. Just see the column that we are saying the 8 number of 12 bars. Here you can see bar size 12, bar number 8. Fine. Similarly for the case of beam, you can say the concrete design. Here it has shown 3 number of 12 here, 3 number of 12 the top, 3 number 12 the bottom, again 3 number 12 the top, 3 number 12 the bottom, 4 number 12 the top, 3 number 12 the bottom. Just see the whole design thing, the concrete design has been given here. The other thing that you can go for deflection, shear bending, loading, property, as far as the thing that you want, you can see here easily. Hope you like this video. See you in the next lecture. Bye bye.